My dear lovely colleagues, are we online? Can I talk? Thank you so much. Welcome back to everybody, like we have not talked in here for 10 minutes straight before. Anyway, I have Bart next to me. We decided to not pronounce his last name because I don't want to make fun out of me again. And yeah, developer productivity shouldn't breach security. My question instantly is, my head goes straight to the question, what should it breach?
Time being wasted. Security should be fun. In that case, we can be productive. And then we can waste some good time on coding.
And that was the whole session. Thank you very much, Bart. Can I leave you? Are you ready?
Sure.
Shall we do it?
All
Give
right.
a round of applause for Bart, and I'm leaving you.
Thank you for having me. And thank you everyone being here for joining us. Also the people online, thank you for joining. My name is Bart Lannoeye. I'm from Belgium, so that's why it might be hard to pronunciate my last name. I like to call myself a technical architect because sometimes I still like to have Visual Studio open, do some coding. You can find me on social media with my full name. Might be hard to type it in as well. And I'm also a Microsoft MVP in Azure, so the topic that we're going to cover today is very related, of course, to Azure. What's not on the agenda may be important to get started. If we as developers think about securing our application, typically you will look at authentication, authorization in front of your application or API. And if you look at Azure, you're going to do that most likely with Azure Active Directory. We're not going to talk about that today. If you have any questions, feel free to reach out. But I hope that you're already doing that. What is on the actual agenda? We're going to tackle everyday challenges between us devs trying to move forward and a chief security officer or IT trying to hold you back in building secure cloud solutions. There are several topics that we're going to address. Why do you need this talk? Very important. First of all, since we're moving to the cloud, the gap between typical development and ops or IT is becoming a lot smaller. You have to acknowledge that there is a security risk, always, and often we ourselves are part of that risk. Also important to know, no company is small or large enough to not be at risk. The only thing that we can do is try to minimize the potential risks. Of course, now you say, Captain, obvious, we know all that. Do we? Earlier this year, even a large company, software company like Microsoft, was victim of social engineering. Someone got their credentials lost, and part of their code base was stolen and put into the open. It's not always social engineering, and it can also be technical. If you look at Crypto.com, they had a faulty two-factor authentication architecture, and they lost over $30 million in crypto, which is quite a bit of money. But it doesn't have to be that big. It can be very small details, like misconfiguration of cloud resources. We're moving to the cloud, we need some configuration, and Flexbooker, who was taking care of COVID vaccinations in the US, they not only had one breach, they had two breaches in a period of only 2 months due to misconfiguration. And one that happens quite often and that we are faulty of as well, leaky secrets. In the end of last year, Twitch came public about leaky secrets. Earlier this year, Samsung and Nvidia were impacted as well. And if you look at in Samsung, almost 7,000 secrets were found in their code base, and once you have those secrets, everything is open in the wild. Now you would think, with Twitch, Samsung, Nvidia, 3 big companies, everyone will have learned a lesson. Well, no. Only last month, Toyota had to come out and say, we also had one of our secrets being exposed on GitHub. Because by accident, it always happens by accident, one repository was public and data of over or almost 290,000 customers were made public. So the question is, will you be next, or even when will you be next? And how can we tackle that? And these days, more than in the past, companies go more digital, and often they assign someone as a chief information security officer, a CISO. And that person, with all the security risks and all the big outings, they're going to yell, let's lock everything down. And then you have several actors in your company who are going to come up and say, first of all, people from finance, it will cost too much. Security will cost often a lot of money. We'll come back to that. Then the people having to do the job, mainly IT, it's too much work to secure everything in the cloud. We're no longer on premise, it's a lot of work. And then we developers come in, if we lock everything down, we can't do our job. That's what they're going to try to tackle today. But first of that, looking at the cost part, security is trying to balance between cost and risk. At the left side, if you do or try to lock everything down with minimal risk, it will cost you a lot of money. On the other side, of course, if you do nothing, it won't cost you a lot. But the cost of a security breach is very high. You could leak a lot of potential and dangerous information. If you look at the balance, there are many angles to approach it. First of all, what business are you operating in? If you look at banking, a banking application, they try to be very secure because it's working with money. If you had a simple cooking recipe app, you still want to be secure. You don't want someone to mess around with the recipes and make someone sick, for example, but it's not as risky as a banking software. If it's a public website, you're open on the internet, and of course the points of attacks are a lot compared. If it's closed off company or factory floor, not connected to the internet, you still will have to implement some security because I could still walk in with a USB stick, so you will need some security, but it's not as drastical as a public website. The second factor, what data are you trying to capture or can be breached? If it's any data that's public or personal, that's sensitive. Name is bad to leak. It's even worse to leak some information like social security number, credit card information, so that's very sensitive. You also have company secrets that you might have that can't be exposed. Versus public data, if we can look at the recipe application, it's all public, so that's less risky to be breached. Now, how will you tackle that in case of a breach? If we look again at the banking application, they will do everything to prevent a security breach because that's very important. In case of the recipe application, well, if someone messes around with your recipe database, hopefully you have a backup, you can restore it, and an hour later you're up and running again. So that's a different part of mitigation. Of course, it's very important to know how will you monitor it, because there has been some research. It takes almost a year between the actual breach and between when people find it. So you need the correct monitoring processes in place, certainly if you have a high risk environment. So if you wrap up all these things, you have to try to identify the threats and assign a likelihood, the impact, and the cost. And depending on those three factors, you're going to make a ranking, and you can spend money on the things that are the most impactful, most likelihood, and hopefully don't cost too much. If there's something with a very small likelihood, a very small impact, and a large cost, that typically won't be implemented at all, because then you have to weigh what is the cost of the actual breach against the cost of the mitigation. Also important, coach each team in your organization on the threats that they can impact themselves or that they can be impacted by, so they can start to live and have an eye for the potential risks. With that, it's very important to say that security is not an afterthought. Keep in mind, it should be part of your whole software development lifecycle. And like with testing or everything else, shift left is important here. Try to keep or bring it as soon as analysis and the design phase, so you already know what you will have to implement or put in place, what the risks are, so you can start to create your software in the right way. We're going to use a small use case to go through today, and I've used a typical website, not a banking website, because they're already very secure, but every single application or website, certainly if it's online, can be or at risk. We're going to host it in Azure, and what we're going to use, simple app services connecting to a SQL database and a storage account. Nothing fancy, just a small, simple website. But it can go a lot wrong, and I'll show you in a minute. First of all, since we have to connect to a SQL database and to a storage account, we will need keys to be able to access those resources. And a security key, normally only the user in possession of that key will be able to authenticate. But Bart, what my team typically says, there's a difference between environments. We have a dev environment. I want to put that connection string in my config file so I can easily develop. In case of an issue with production, I'll change it, but I won't commit it. And for that, you can even use a git command like git assume unchanged in your settings file. So whatever change happens, it won't be committed until a new team member joins the team, goes to production with the credentials that's somewhere on Jira, because we never share credentials, and commits that after all. And don't say that it doesn't happen. Here I have a commit by my alter ego, and the credentials, including password, are in source control. Luckily, this is a private Git repo. If it would have been a public repo, you can be sure that there are bots scraping, and if it's compute powered behind it, like an AKS cluster, they will be mining crypto, and you will be paying the cost. So a solution for that is, instead of putting the credentials in our configuration file, maybe we will let the CI/CD tooling fill in the secrets during deployment. That's a very good idea. We no longer have them. But what about the local development story? And you still need some secrets there. And one of the downsides, if you inject the secrets during development or deployment, that they are still readable in the cloud. Let me show that. Here I have my fancy API, where I'm gonna get weather and forecast and history. And if you look at the URL on top, I simply copy that over to a second tab, and I added SCM in front of Azure Websites.net. What does that do? It will give you the Kudu console. It's a very powerful tool to see what's actually running on your app service. And you have tools like here, like let's do a new deployment and screw this up. Or, maybe even more important, let's open a command window. Now it does a small loop to authenticate me again. And not only do I have a console, but I can browse through all the files up here, edit the app settings, and here are your security credentials. You thought they were safe, but I can still see them. So Azure does have a solution for that. It's called Azure Key Vault, and every single secret that you have should be in there. But again, what about the local story, the local dev story? And if we put our secrets in Azure, don't we need a key to access Azure Key Vault to get those secrets out? You would think so, but also for that there's a solution. First of all, for the local dev story, we have a secrets manager, a sort of safe on your own computer, so you no longer need to add the credentials in your app settings. And for Azure Key Vault, we can use managed identities. You might have heard about managed identities before in one of the other sessions, but in short, it's a security principle that lives in Azure Active Directory, and there are two types of them. First of all, there's a system assigned, that is part of the actual Azure resource. And then there's a user assigned, one that you create yourself, that you can assign to multiple different Azure resources. If you don't want to manage, let's say, 15 different managed identities because you're doing microservices and they are all deployed as a single monolith, then you can simply use a user assigned one and reuse it. What are we going to do with that managed identity? We're going to give an Azure resource, in our case, the app service, an actual identity to authenticate versus another resource. And you will see on Azure Key Vault, I'm there as an administrator, and my app service can be a Key Vault reader, or even better, you can give it an access policy. So if I switch to the Key Vault, you have some secrets in my secure database and my storage that are hidden in here. And you can then go to access policies. And if I see access policies, my web or my app service only get the permissions to list the secrets and retrieve them. I try to limit this as much as possible so they don't have full access and they can't tweak them, only the minimal access required. If you go back to the keys, what you would, the secrets, what you would put here and here, you can still place the full connection string to a SQL Server, but again the same concept. If we go or use a managed identity to go to our Key Vault, we can also use managed identity to access our storage account or our SQL Server. So the actual SA password or the access key for your storage account are no longer needed. What we'll typically store here is the name of the service and the location endpoints that we can access, and all the rest of security we will do through managed identities. That brings us to the next step, RBAC, role-based access control. Like I've shown, I have my access policy with minimal access. If I want my managed identity to access the storage account or to access a SQL, I will need to give a role on those resources as well. The concepts between role-based access control are very simple. You have a security principle on top that can be a user, a group of users, an application, or a managed identity. You have role definitions. Anyone already using Azure most likely will know the owner, contributor, and reader roles. Those are the three default ones. But there are a lot more built-in ones that are very specific for every resource. So in our case, for Key Vault, you could say Key Vault secrets reader. That's only limited to reading secrets and nothing else. Then you have a scope, management groups, top level in Azure, subscriptions, resource groups, and then the actual resources. The combination of those three are a role assignment, and that will give you access or deny you access to a given resource. Always try to use the smallest role definitions possible and the smallest scope possible. So we have the least privilege principle, that we don't give someone full access to a whole subscription if that person or that identity only need to have access on a single resource like a SQL Server. But Bart, there's a difference between environments. No, I want to have more access on dev and maybe even on production. Well, in my opinion, no, but I'll humor you. We have a possible RBAC structure where in production, in my opinion again, a developer should only see the resources if so in production and not have access to the actual data. Certainly not write access. Never change the data in production. Never run a SQL query in production because you will mess up. If you look at the other environments, you can maybe give them more access. But if you consider about restoring production data to a lower environment, always try to cleanse that data, remove the PII data, so data doesn't get leaked because someone has access to a lower environment as well. If you look at security, every access where or every environment where data is should be regarded as production. But Bart, what if I want to do support? I want to change something on test, maybe even look into data for some reason in production and I can't look it up through my API or my application. I need to check if something is correct. Let's put myself here as a contributor, as an owner. Please don't. There's a solution for that as well. Azure has something called PIM, Privileged Identity Management. And for that, sadly you will need a premium P2, so the most expensive license on Azure Active Directory. And this allows you to give elevated access, just in time, so only when it's needed. When someone needs it, you can enforce that that person uses MFA. You can even add require approval, so someone has to approve it. You can do access reviews, who is eligible to ask for more rules, and maybe even the best thing, you can put notifications on top of it, and there's a full audit trail. So if someone at some point needs access to production, goes through PIM, asks, maybe fill in a form, gets approved, everything is logged. From security reason, there's a full trail what's happening. So what we're gonna do, we won't leave the door open, we will only open the door when you need it. The third one, if we look at security, the pitfall of great tooling. We're happy to be able to use tools like Visual Studio Code, maybe third-party tools like Rider. They're very handy, and anyone who has already tried to publish something to Azure in Visual Studio, it's 4 clicks and your code is up and running in Azure. Very fun, very fast, but not the best security-wise. But Bart, there is a difference between environments. I want to right-click deploy to dev. I want to test out things. No, friends, don't let friends right-click deploy. Use those Azure tooling and all the great tools in Visual Studio Code, Rider, any of the tools. For speed during research, during POCs, when security is not an issue. But once you're building production-worthy code, don't use those tools. Build and deploy should be done by using automated pipelines. I hope most of you already know that. I hope most of you already use it. You're going to build it, you're going to do some testing, unit testing, integration testing. You have a single artifact, and that artifact will be moved across your environments from dev to test to staging to production, and the only thing that will change is configuration. You won't change secrets because all your secrets are in the key vault, but you will point to that key vault, and you will change the endpoints of the configuration, maybe the scaling of your instance sizes. And also that part can be done through pipelines with infrastructure as code. But Bart, there's a difference between environments. Why else do we set up those environments? Okay, you asked it 4 times now. I will give you your different environments. But security-wise, all your environments in your release pipeline, from dev up to production, security-wise, they should be considered as production. You don't want to leak your secrets, so even your dev secrets are not going to be placed in your configuration. You've seen what happened. You're not going to break your production manually by right-click deploying, because we don't give you the rights. You're not going to break production by CI/CD, because what do? We build our pipeline once, we copy it over, and we forget to change an endpoint to another environment. Now what we're going to do, we're going to use a service principal with the rights only for that given environment. So a security principle for dev, another one for staging, another one for production. So even if you copied it over, we do it. I've been a developer myself. And you forget to change something, that pipeline can't break by accident another environment. We're going to prevent lateral breaches because we're limiting that role-based access control again. So if one of those accounts is breached for some reason, they can't go to other environments. And we're going to prevent non-production data breaches by protecting every single environment. And in case of a restore, we're going to cleanse all the personal data. And that's something that most companies don't do, but they should. So we don't restore a full production copy in development and then say, yeah, we have production-like data we can develop now. You can do the same with clean data. But Bart, you're nagging. I can't work if I have, if everything is locked down, if I don't have a dev to try out things. I want to do research. You can. Everyone who has a Visual Studio subscription can create an Azure subscription with it, with credits, monthly credits, $80 or $150. And if it's at the end of the month, you have an issue. But the next month you can try out things again. Or you can ask your company to create one big subscription where you can test out things. And these are called sandbox subscriptions. You're going to put them in another management group where you typically use for role-based access control policies, things like that. And you're going to put them on the side with different access control. On this subscription, you can be owner, you can do everything what you want. I don't mind, but it's not connected with these data. You can choose either you link those subscriptions to your main Azure Active Directory, but often what you will see is that you spin up a new Azure Active Directory, because one of the first things that you will do as an application developer, you will want to protect your API or your website with security, Azure Active Directory. You will need an app registration, and we'll put them in here as well, and not in our main Active Directory, again limiting the attack surface. Now we have our clean environment. Everything should be secure now. Almost. We're still on the internet. Time to lock the network down. Remember the old days, most companies still have those, where you have an on-premise solution, where IT is boss, where you as developer couldn't do anything. You have the internet on one side, the enterprise LAN on the other side, some nice big firewalls in between, a small DMZ network for your web servers, and they did everything so the internet couldn't cross over to the enterprise LAN. Works perfectly if set up correctly. Now if we move to the internet, we have some issues. But maybe first, let me show on my API where my alter ego did commit the secrets, so I can easily use them to demo it. I have a connection string for my database, my storage account, and my API is as fancy that it only needs 2 endpoints, one to get data, and I'm gonna simply use the connection string, a SQL connection, do a call. I'm not even gonna bother querying. If you did look at the top, my query is select 1. We all know that's simply gonna return 1, but that is more than enough to trigger a full round trip to SQL Server. So that's all what we need. Doesn't matter what tables are in there. So if you ever want to create a health check that checks if your SQL Server is still up, select 1 is more than enough. It doesn't take complex queries. It's not going to bring your database to its knees, but it's more than enough to do the round trip. So I'm going to execute that, and then I'm simply going to return some data, the default code from the web API, nothing fancy here. And then I have a second endpoint that goes to the storage account, blob container client, and it gets a simple CSV file and will return that. So if I run that API, I get my Swagger, try it out, execute it, and it blows up. Cannot open SQL Server request to log in, client with IP address, where we are now, can't access it. Not a problem, it's a demo. So, Azure SQL is one of the few services that already come with decent networking and firewalling in place. So we're bugged now, but they have a nice link at your client IP address. Save it, and if I would run it again, it will go through. You might see here, what do we have? The IP address that I just added now, which I will forget next week why I did add it. I do not delete. For some reason I can't delete it. IP1 and a home IP address. And if you have any decent size team, within a few weeks you have 20-25 IP addresses here that all are small holes in your firewall. So that's one of the first issues. If we look at our key vault, networking. If you think about network security, almost every single service in Azure has a networking tab. Allow public access from all networks. So we just open it up to the internet. Perfect. I already showed you the Kudos console. I've been doing it from here. So it's open. What you can do, also change your files. Your web app, change from the Kudo console. Open to the internet. Perfect. And there's one that I didn't show you yet, but you can guess it. Storage account, open from the internet. So we've built a very simple solution, and every single resource in there is open to the internet and possible to be breached. Why is the SQL database not crossed here? Because all the networking part is done on the SQL server. This is an actual resource like you would have a storage container in the storage account, but every single one can be breached. It's networking, so how it's gonna solve network security, and that's most of the times when you're gonna call in IT, because we're developers, we don't like networking, but you should know about it, at least the concepts. And Azure Virtual Network is your primary component if you look at that. When you set up an Azure Virtual Network, we're still working with past components. We have an app service, a key vault, a storage account. Those are resources that are shared by everyone using Azure. It's not your own VM that you put in there, it's a shared resource. So what we will have to do, we will have to use private link or private endpoint to bring in those components in our own virtual network. And once we do that, Microsoft is going to put some firewalling in place that it can't be accessed from outside your virtual network anymore. So they're going to take care about that part. And once everything is in your virtual network, you will have to expose your application, your API to the public. And for that, you can use Azure Firewall, the typical firewall that you know for on-prem as well, a cloud counterpart. Front door is to expose a service HTTPS globally. Application gateway does the same, but then within a single region, a bit cheaper because it's a single region. And if you look at APIs itself, you can use API Manager as well. Next to the security part, there are a lot of other things that API Manager brings, but it helps for security as well. Often what you will see is that we try or start to combine these services, an application gateway or a front door in front of our API Manager as well. Which brings us to something like this, a bit more complex that we've seen before. We have our whole VNet around the application service here, so nobody can access the application service anymore. We have API management in the middle to route all the requests. Our React, Angular, Blazor, whatever website is hosted on a static web apps and will query the API management service. Everything is protected by an Azure front door. Like I said, we have our shared PaaS services, Key Vault, SQL database storage. Those will use private endpoints, so we can access that as well. Looks nice, looks fancy, looks expensive. It is expensive. Like I said, security always comes with a cost. But often, if you're building in the cloud and you have data or anything that has to be secured, the actual cost of adding API management, front door, application gateway is something that a company wants to take. The good news is everything is locked down. The bad news is everything is locked down. We are developers. We want to access those resources. First thing, since the application service is in the virtual network, you can't access it anymore, so you can't right-click deploy to it anymore. Good. Never right-click deploy. Bad thing is, if we can't right-click deploy, then Azure DevOps, GitHub Actions, or any of the other CI/CD tools can't deploy to it either, because it's in a network. The first thing that you might want to do, let's open up a port, so the CI/CD can go through. Don't. You want to keep that network closed. The solution here is that you're going to self-host a VM or a container on container apps, container instances, maybe even an AKS, doesn't matter, but you're going to self-host your build machine and put it inside your VNet. It costs a bit of money, but it's secure. And then the final part, if someone has been working on premise for 10, 15 years, that they could simply log in, hopefully with an admin account, but often with their own account, on the server to look at the database, they're going to say, yeah, you locked everything down, we can't access those components. And I want to verify something. Again, you have to know, do you want to give people access? In my opinion, if it's simply data, either your application should be able to show it, or you have a specific tested tool that accesses, but in case you want to access it, you will need to get in that virtual network. There are some services. The first one is Azure Bastion. Azure Bastion is sort of a jump host that is already in your portal. So you go to the portal, you go to the VNet, and you have Azure Bastion in there. So you already have the security of the Azure portal, and then you have an extra security step that you go into that jump host before you access something like a VM. Since we have a network, we can connect with that network, so we can put a VPN gateway in the network, and we can use either from our on-site, our corporate network, a tunnel to there with a VPN gateway or an express route, or simply from your own laptop, install Azure Client VPN. You can connect into the VPN. You're inside that virtual network, and you can do everything again in that virtual network. The third option is Azure DevBox, which is currently in preview. It's simply a dev machine that's created by Microsoft. You don't have to set anything up, and you can connect that to an Azure Virtual Network as well. And this solves the bad laptop problem that you often have as a consultant. You have to use a laptop of a client, and it has 8 GB of RAM. Simply use an Azure DevBox. You can put as many RAM into it as you want. You will only pay for it, but that's normal, no? Like I said, a lot of options, Azure Bastion, DevBox. Again, it will cost you some or a lot of money depending on what you want to do. But that's the problem of the security officer. He wants security, and he has to battle with finance. And then finally, I hope you're all convinced that we have to do or have to pay attention to security, and say, Bart, we believe what you say, but we're working in Scrum, and we'll work on features first, and we'll add security before we go live. We should know better, no? When was the last time that you did underestimate the complexity of something that you don't do every single day? When was the last time that you did finish a large project without bugs, on time, and you had enough spare time to implement something as complex as security? And when was the last time you implemented a major change the week before a release and didn't regret it? I've been a developer as well, and I've been there. Security is not an afterthought. So, I've shown it before, bring up security, the needs, as soon as the very ideation phase of a project analysis design. Think about it up front, think where the needs are, and implement those needs as soon as possible. You're going to have to fine-tune the needs according to your cost. You're going to see some needs or some requirements will cost a lot, and maybe you will push them backward, or even the security officer will sign off and say you don't have to implement that. But it's always important as a developer or as an architect that you have someone of management that they know what the impact and the risk is, and that they sign it off and don't do it yourself. Implement the security measures as soon as possible. Shift left also counts for security, not only for testing. Coach your teams to work in a secure way. The things that we've shown today, don't commit or put secrets in your configuration. Start working with managed identity. Take all those secrets out of your solution. Think, in case that you need networking, do it from day one or as soon as possible. Even a few months ago, I was architect on a project where they said, we're going to do it in the end. It was painful, so do it as soon as possible. Get help of experts. They can be internal in your own company, they can be external, but security is so important and that it has to be done right. It's so easy to mess it up. So get help of experts and have tools in place to monitor. We didn't cover those today, and we only had 45 minutes, but there are security checking tools during CI/CD. You can have Git hooks that prevent you to commit keys, and once you're running, here Azure Defender, Azure Sentinel are solutions from Microsoft, but there are so many other solutions as well to also, during the run phase, check your security footprint. So please use those. A few resources to wrap up. If you want to learn more, as always, Microsoft Docs, Microsoft Learn. 5 years ago I would have said, look somewhere else, but they did put so many effort into writing good docs. Certainly go there. Cloud Adoption Framework for Azure. If you look at the bigger picture, certainly if you're a software architect or looking into software architecture on Azure, look at that as well, Cloud Adoption Framework. It will touch a lot of infrastructure, security, governance points as well. Azure Architecture Center, it has hundreds of architectures for specific scenarios, and that's something that I want to point out. If you look at it right now, 828 results. And if I say secure, implement a secure hybrid network, secure DevOps for AKS, more than 400 results that they help you to put up a secure solution in Azure. Have a look at it. It's only a start, but it's a very good head start. Finally, to conclude, certifications, some people like them, some people need them, but what I like to bring with it is the learn part. Again, Microsoft Learn, they've put so much energy into it. Learn to use the technologies. As an Azure developer, at least the first one, the 204, go through it so you know all the resources in Azure that you can use and how to use, maybe how to use them, that you don't do it wrong, that you use the right security aspects. If you want to go even deeper in security, the AZ500 for security technologies, or the administrator one, focusing on role-based access control policies, networking, are interesting as well, but if you start with the 204, it's already a very good start. With that, I would like to thank you for being here. Like I said, my name is Bart Lannoeye. You can find me on social media, Twitter, for so long it's still up. Maybe I'll move to Mastodon as well, but also LinkedIn, Reddit. Look at my full name, you will find me. I have a blog where a few of these things are already posted or will be posted soon. Same with securing your API with Azure Active Directory. It's also up there. And with that, thank you for being here, and if there are any questions, feel free to shoot them now or afterwards.
We do have a couple of minutes for live questions here, not just catching you outside. Anyone would like to be curious at the moment? No, the session was so clear, everybody's either asleep or very knowledgeable now. Okay, so if you don't have any questions now, ask them later, and that's it. Thank you very much, Bart.
Thank you.
We have one more session after this in 15-20 minutes.